Right. Presumably I've turned my microphone on. Please confirm.
We can hear you.
Hey, oh, you were just too slow. I was looking. I didn't know before I minimized it. Right. Well, lesson of the I've learned today is never go second when Q is first. So, but never mind. So encrypted SQL playtime, I was just going to have a little play with it really, show you what I've done. It's quite a handy technique. You may come across this requirement, so it's nice to know it can be done. I'm not going to do anything about me because I don't know, I've just gone off the idea this week. But if you are interested in who I am, then look up DSH workshops. In fact, look up DSH workshops anyway. Just for So I'm going to go straight in. So what is SQLite? So I use SQLite a lot, and it's a very lightweight SQL database or SQL database to be used, and it's to be used by applications. So it's a single application will tend to use a single filed SQLite database. And you can see here that the way it talks is through your LabVIEW program, which then will chat to a DLL, which will chat to one or more SQLite database files. And that's it. And that's all there is to it, which makes it very nice. And it is used everywhere. So got it on your phone, iPhone, Apple use it, Android use it for sort of phone stuff. It's just everywhere. But we can use it too. It's extremely quick to read, quite slow to write in its normal form because it uses a safe method of storing data, which is to store it and then one disk cycle later to check that it's been stored. So there's always a cycle time there, but there are ways around that because you can. It's so light and small, you can run it in RAM essentially. So and that can speed it up. So it's great. Everyone should use it. If you're using any files, don't use any files anymore. Use config. Use SQLite. So I have just a quick look. I use Navicat. So this is just what a database in SQLite looks like. So let me kill those. I'll be looking for them later. So there's various tools. This is actually a paid one. And they've changed the interface and not for the better. But never mind. But there's plenty of freebies, and we'll come into that in a minute. But this is a standard little database. It's got tables. These are tables. And if you want to look at a table, that's the data in the table. I like Navicat because it gives you the SQL at the bottom. So if I deleted something, it would tell me the delete statement. If I insert something, it would tell me the insert statement. But it's also got a very good query builder, which allows me to build new queries. And in databases, queries are key. Drag tables in, and then you can make complex relationships between tables. Unfortunately, that's two tables that haven't got a complex relationship, but you can link them, and then you can do a complex query, which I may show later. But and then it converts it into SQL. So let's just have a look at. So one of the main sort of parts of our template is we use it for our system config. So this is a standard sort of system config for one of our systems. And the good thing about it is you can version it. So it means you could have multiple versions or multiple configurations, and you just point to them, which is quite handy if you've got different hardware setups, for example. Just change the configuration and away you go. Very nice. Okay. So I tend to do my slides as just an aid for my old brain. So hey, I managed to get it right. So I'll get out of order almost entirely because I'll start chatting about the things I shouldn't be chatting about. So how do we get it into LabVIEW, and how do we use it in LabVIEW? There's various toolkits. There's paid toolkits. I can't remember who does it, but there is a paid toolkit. I tend to use James Powell's toolkit because it works very well, and it's a freebie, and I like freebies. And it's open source, and I like open source. And you'll see why I like open source in a minute. But generally, if you just download that on VI Package Manager, that's great. And then what I'll do is I'll embed it in my project because I don't like stuff in my VI library. So then this is how we embed it in our project. We just drag the files over and then it's in our project. So this is our main template project. And because it's good software and James writes nice software, it just moves. You just move it over because he understands portability. So this is how we use it. So we use it for configuration. So again, all of our applications use it for configuration. But the good thing about it is if you want to add something like calibration to it, you can just take the same file and just add a table. So you could use it for calibration. We use it for error logging. We use it for settings. We use it for results even. It's a very good medium for storing results because it's slowish to write, but very quick to read. You know, for customers and certain applications, you may want to sort of filter a lot of post-processed results. It's very handy for that. So these are all projects that we use it in. This templates and various other bits and bobs.
So Steve, you say it's slowish to write, but quick to read.
Yes.
Can you elaborate?
I can't give you figures because it really depends on the CPU and the disks and the, you know, so in this world of solid state drives, when I mean quick, I mean really quick. You know, you can pull a lot of data off this thing. So James has done a couple of things for CSlug and he's pulling enormous amounts of data off, you know, in sort of milliseconds. It's really quick. To write, you're limited by your hardware again because of the disk speeds and things like that. But again, I haven't tried it on an solid state drive. You probably find it's fairly quick, but there's always a. I mean, most databases are the same. They're much more slow to insert than they are to select, as it were. So I can't give you real numbers, but I've done a couple of benchmarks just testing out how much slower the encryption is, and it is markedly, you know, it's factors faster to read than it is to insert. There's things you can do about that, so you don't have to insert one row of your database at a time. You can block insert. That speeds things up massively. So there's lots of tricks you can play, and there's also you can run it in RAM, and of course then you're restricted by the clock cycle rather than the rotation of your hard drive. So, but you just have to. It's just you're then starting to dick around with things that aren't normal, as it were. But it can be optimized quite nicely. I mean, we've always found it to be really efficient. So I've never lost any data using it. I've never had any issues with it at all, really. Nothing's ever corrupted. It's a wonderful piece of software. So I haven't answered your question, but I don't know whether I can.
No, it was clear. Thank you.
Okay, so that's just SQLite. Again, I can show you more about that, but the next thing that people want, especially when you're doing things like results, is they sort of say, well, can we have it encrypted? And that started, and it actually was Campbell that asked me. He said, oh, can we do this encrypted? And I thought, there must be a way. So I started looking around, and SQL Cipher from ZTIC, they do it, but they do it in a C++ kind of fashion. In fact, that they give you a text file, and you've got the opportunity to build it into a DLL yourself. So me being a LabVIEW programmer, instantly got bored and thought, wow, there must be a better way. I'm not going to load up all these things and build text files. So what I found was there was a another freebie download called SQLite Browser.org. And they've built that DLL for me, and they've also built a couple of quite nice tools. So you download those, and what you get is these two pop up on your desktop after you've installed them. So let's bring it over here to the white bit. So you get two browsers this time. You get one which is your Bob standard SQLite, and then you get one called SQL Cipher. And if you look in SQL Cipher, and I'm getting ahead of my slides here, but I do have slides. I may include them if you want the link. If you go into SQL Cipher, you can see it's quite a lot of DLLs. So anything marked Qt, you can ignore. Qt is to do with user interface generation, so we don't care about any of those. So the only things left are SQL Cipher, SQLite DLL, and the two libraries here. Now, SQLite is your non-encrypted. SQL Cipher is the same, but with a couple of encrypted options. And the fact it's the same is bloody brilliant, because all we need to do is take those VIs and chuck them over here into our embedded SQLite James Powell toolkit. So here's actually I've taken out the unencrypted ones just to stop people messing around with them. But generally, you just replace the SQLite DLLs and SQLite 64-bit DLLs with the ciphered versions. That's nice. And then James was very nicely in his open class. So this is in part of his toolkit. If you go openstring.vi, it will take you to here, and you can actually just call the specific DLL. So if you don't feed it a library path, you just call the specific DLL. So I kind of liked renaming. So the other bodge I could have done was taken the SQLite and named it the same, but I didn't really want encrypted stuff sort of polluting my other software. So I kept the naming the same and just generally just changed it. And then it just worked, which was lovely. So in its non-encrypted form. So that's the thing. Unless you applied an encryption to it, it'll work just like SQLite. It'll be a bit slower, but it'll work like SQLite, which is very good. So let's have a quick look at encryption. I did this earlier this morning, and lots of things have happened since then. Okay. So here we've got my config database just as a standard. So if we look at it in Notepad, you can see stuff. So that's not very encrypted at all. So I've just made a copy because it destroys the original, and I may want to play around with it. And if we then load SQL Cipher, and we go open database, go to him, and we open him. It's quite a nice little utility, this. It gives you all the creation tables, do it yourself and things like that. You can actually browse the data, which is nice. So that's all quite cool. So that's all nice. I like all that. And then what you can do, actually, I'm going to open another data. I'm going to open the copy rather than ruin the original. If I then go tool, set encryption, I say DutLUG is my passphrase. Bloop. Now it's saying, oh, login. You've just changed something here. And we're back. So it's back, but now it's encrypted. So let's have a quick look. Kill him. You can see he's done a bit of maintenance. There's a very nice SQLite command called vacuum, which takes out all the empty stuff. So a SQLite database will grow and grow and grow. If you delete stuff, it won't free up space in the file. It frees up space in the database. So if you want to squish it back down again, you can use the vacuum command. So they've done that, which is nice. But now if we look at that, I can't make head or tail of that. That's all foreign to me. So that's all nicely encrypted. So that's cool. But how do we get that to do that in LabVIEW? Well, I've already shown you half of it. I've shown you how to link to the DLL. So that DLL is ready to go, you know. But it hasn't actually got the encryption functionality in it. So very, very nicely. Oh, I suppose I can make that bigger. And I'll dig around in the software a bit. Oh. To actually encrypt it, what you would do is open an unencrypted database, and then you would apply. Oh no, you'd open your encrypted database. This is to open encrypted database. ConnectDB encrypted. Okay, so you open it, and then you would apply the password, which is just another SQL command. So just give it a SQL command, which is pragma key password, and then you're in. So it's all working. So the way we do it is that we do everything using templates. So we don't really do much what you would call normal reuse, but we do an awful lot of template reuse. So all of our projects are generated with this base template. And now I've got a project that's got a base encrypted template. So let's have a quick look at the template. So in this template, I use SQLite to do the configuration, and I also use it to error log. So if I go burp, there's an error. If I look at error history, I've got my error history. So I've had 4 of those errors, 9 of those errors, something like that. And then we use it for configuration. So here's the configuration. You can have a different version. So that's just being standard sort of SQLite and template. So this template does all the things we want as a company. So this one here is the encrypted version. You see it's exactly the same, apart from it's encrypted. And bloop. So now here I'm pointing at this database. And here I'm setting my key. So I then set key, blonk, and then when I connect it, encrypted, I'm setting the pragma key, which is just essentially it's applying password. And key and encrypt database. So the next things you may want to do is actually in LabVIEW encrypt a database, and there's actually a bit of a procedure to it. So what you have to do is open your unencrypted database, attach your database to another database. Then you encrypt it, I think. Yes, right. You set the encrypted, you encrypt it, then you detach it, then you delete the old one, and that then opens it, you know, so you don't have an unencrypted one sculling around. So there's a bit of shenanigans goes on to actually encrypt it. But I tend to just use that because it's a bit easier. But you know, you may want to encrypt stuff on the fly, or allow, say, a customer to encrypt their own or apply their own password and encryption to their own results, as it were. So you could be doing that kind of thing, and you would use that to do that. You would bring in a plain template, give it a password, and away you would go. But apart from that, it works just the same. And because it uses SQL, it doesn't change any of James's code at all, apart from the initial, what DLL do I want to point at when I open? So I'll tell you what, just to prove that I'm not a liar. Connect encrypted. Encrypted. Here we open it. That's opening the file. That's now we're down to James's string, and there he is. So just pointing to that cipher, and away it goes. This is going to be a very quick presentation because that's about it. Unless you want me to poke around in the code a bit more, we'll show you a bit more. Go a bit slower.
So, Steve, I have a question from Samuel.
There we go. Yes. Right, go Sam.
Can you hear him? He missed where the encrypted DLL came from. He was asking, where did you get that?
Okay. Let's do it, shall we? Because we seem to have plenty of time. As ever, my attention span is only about 10 minutes, so I usually finish with my presentation within that time. So if you want to know how it's done, this is the C code. So if you want to go that deep into it, if you're lazy like me and you just want the DLL, it's SQLite Browser.org. So let's go and have a quick look at SQLite Browser.org. Now if we go and download it. So here you got two options. So if you want the 64-bit, it's there. So let's download that. Oh, my internet's actually relatively fast today. Doesn't. Okay, that's it. It's in. Now you just install it. Let's skip both of them up. So this is if you got 64-bit LabVIEW. I'm still very old-fashioned. I like my 32 bits. Got to go really slow now because of TeamViewer or something. Let's see. Okay, so let's go find in, shall we? This will give us the 64-bit version. Let's redrawn my 64-bit version. Yeah, just program files, isn't it? There's our 64-bit DLLs there. So yeah, it's as easy as that, and you just just nab them from there. And so when you install James's toolkit, it goes into the VI-lib, I think. It's been a long time since I've whipped it out of the VI-lib. So we just tend to take it away from the VI-lib and bung it into our projects.
So Samuel asks, so the cipher DLL simply comes with SQLite?
Nope. It comes with this download, which gives you the cipher. No, that's the one that comes with SQLite there. That's the standard. And that is exactly the same, apart from it can understand the pragma command, which encrypts the database. So it's got exactly the same commands. It's not in any fashion different. So it fits very nicely in James's toolkit because everything works exactly the same. But the only difference is you do the pragma command at the start, and that just encrypts your database or unencrypts the database.
Is the SQLite Cipher DLL also open source?
From a license perspective, it's not open source, but it's licensed as a freebie. It doesn't seem to have any licensing issues at all. So it's let's have a quick look at the DLL. Actually, no, it is open source. It's open source because it came from that Zetatech website I mentioned. So yeah, it's both. So Zetatech. Let's have a look. So this is actually an open source specialized build of the SQLite transmitted on the fly encryption. Oh, and that's the other thing. It's on the fly encryption as well. So the database is encrypted until it pops out of the DLL. So it's pretty secure. And if you go into it's quite well documented. It tells you how it does it, what the algorithms are. So yeah, it's pretty good. So I hunted around on this site. I thought, oh well, they must have a DLL then, the lazy people like me. But no, they don't. You can download it and build it yourself. Unbelievable, but it's cool. It works very well.
We have another question from Martin.
Hey Steve, so I was wondering, do you know if it's only the storage that is encrypted, or is it also the data when it's being sent over, like when you do the query and you send it to the database or get it from the database, and the database would be, for example, on another PC? Do you know if the transfer is also still encrypted and it gets decrypted on your LabVIEW end, or does it get decrypted already at the end of the DLL, so on the storage side?
I think it's as soon as it hits the DLL. I will do a Wireshark check actually.
Yeah, that wasn't my question. If it's in between, if they're also already encrypted, that's for remote databases or some kind of application of like that. I could imagine that it could be fairly important to also transfer it, maybe encrypted.
Yeah, interesting. Very interesting. I think all the traffic will be encrypted as well. I will confirm, which I can confirm. Well, so let's check. How much time we got?
So around 8 minutes, but take all the time you need.
Okay, so if we bung that to there. Probably not going to be able to do this on the fly. Let's just break that. That's the easiest way. Yes. Okay. So so this machine here is another computer. That's actually the wrong one. Get that. We then want to go and take the Cipher one. It's not that one. Oh, I know where it is. Bear with. So that's the one. Somewhere right. If we take him and we move him to there. The trouble is I have no idea what port that's going to start saving it to, because it's a shared file port. that may work. He says. Yeah, that's worked. It was a bit slower. And the only thing I won't be able to do, I could probably double the test up if, to see if that's over there. So if I run Wireshark now, I'll do it on the other computer and I'll show you the results, because otherwise I'm just going to pick up all this remote nonsense. Okay, try that again. God, all sorts. All right, let's stop logging. And then go look him. Right. I've got no idea what I'm looking for there. So what are we looking for here? This is on Wi-Fi. So he's 207. The source is 207. Ah, there we go. Look. There's all of our responses. So SMB, which is shared. SMB is Samba, isn't it? So I'm sharing the hard drive. So I'm storing the data to the hard drive. And so if I go IP source equals guessing 251 is my 2.168.251. What done wrong there? Oh no. 1.251.
You know, you could just right click on the source and click use this as filter.
Ah, yes, I always forget to do that though. But I'm glad you said it. I could probably do a search for the text, but I'll do a quick. I can tell that's all nonsense. I see no hello DutLUG. What's that? I'll probably, if I did the filter for the SMB as well, that would help us. Quite near the end of the. It's not a very good test, but my guess is that it's encrypted as soon as it hits a DLL, and then the DLL goes looking for the file. That makes sense, doesn't it? It would be daft to do it any other way.
I guess so too, indeed, but it's a nice test.
I will. I'll back it up with a slightly better. Well, once I've got time, I'll do a quick search. I think you can do a textual search in here for something, and then that'll do it. But as you can tell, I'm fairly ropey at Wireshark. So, but yeah, I think it's great. And it was one of those ones I wanted to fix, because whenever you tell people you're using a database, the next question is, well, can you encrypt it? And now you can, which is cool. I don't want to save that particularly.
So I have a question. If you have a project for a customer, and the customer, and you tell them you are storing the configuration of the application and maybe the measurements of the measurement data in an SQLite, and they say, okay, but I cannot open that in Excel or edit it in my Notepad. What do you say to them? Do you give them a tool to access the SQLite, or?
We always have what we kind of call an air gap between our data, i.e. our results, and the customer's data. So pretty much all of our designs are is we have our data in our format, and they get their data, you know, however they request it. So yeah, in short, we have it in a database. If they want it, they can have it out to execute to Excel or whatever. I've got all the tools to sort of do open document format and stuff like that, so you can have it pretty easily in any fashion you want. So that's generally how we design projects. It's to have a layer of data that is ours, and not the. I'm not saying the customer can't use it if they don't want to, but it's not being designed for them. It's being designed for us to allow us to give them what they want.
So that is very interesting. So by default, you store it in your SQLite database, and then you export it from the database to convert it to whatever the customer wants.
Yes, and that allows us to always be able to do filtering, you know, offer filtering and all sorts of things like that. Whereas if you're constrained by whatever their requirement is, you know, comma separated file, well, you've constrained your design then. And so it's you know, we try not to let customers constrain the design in that fashion, you know. So that's generally the way it works.
Interesting, yeah.
Quite a good answer that off the fly. Hadn't really thought about it until then. Okay. That's it. I'll stop sharing. I can find the button.
So we have another question from Roger.
Mm-hmm.
Yes. Hi, Steve.
Roger.
I saw you also store different versions of your application configuration in the SQLite database, and also split them up in sections. Is that possible to show us how you did that, or is that IP?
No, don't have IP, mate. I've got time for such things.
Yeah.
So generally, when we've designed the configuration, it's so in its simplest form, the table just has its version, which is that, and the section name. So that's just essentially allows us to have different configuration sections. So I've only ever really used more than one in a couple of programs. I had one program which, you know, they wanted sort of different machines to have different sets of data, and so we would have a different sort of configuration for those different scenarios. But generally, we get most use out of the versioning, and you can actually just set yourself up 1 or 2 or 3 versions. I've even cheated to a point where actually it's not really a version. You know, it says, oh, if it's this type of logging, then it's version 15 or version odd number. It's a bit clunky, but you can do it, and it allows you to do those kind of things on the fly. From a design perspective, that one disturbed me because it was a bit bodgy, but it was a quick requirement. So, but generally, the joy of having this as part of your config is if the customer comes to you and says, "Oh, I want calibration, please." Oh, so hey, it's quite a good one. Say, well, this machine, for example, has got an interlock, so we just want to be able to set the interlock. So this is another table, and this is a table that allows them to just bung in the state and what switchery they want to do for that state for the hardware. So, you know, the hardware's got sort of 50 states in the state machine, and when it enters armed waiting, for example, it will set these relays, and one of them could be an alarm, and that's just a binary number of 16 relays. So it just allows you to, that to implement took, a quarter of an hour. It works really well because essentially that's one little trick that we do, which may or may not horrify people. I don't know. I don't care. So what we do
Steve, right now you're not sharing your screen.
Oh, I stopped, didn't I? I was busy showing a screen. There we go. Sorry. Oh, can't even remember what I was doing now. So, yeah, if we look at our general template, what you would go. So you missed all that exciting stuff I did here. So this is a table of the relay setting, and so here's all the different states that we're applying relays to, or nothing. And here I said with the armed waiting is we're just setting various relays up, and one of those is you can only actually fire the experiment if it's in armed waiting. So it stops accidental sort of firings, and so it's a hardware interlock, and you can put warnings in here and things like that. So it allows the customer to sort of do that, and it really took no time at all to implement that, because we already had all the database infrastructure already. With the configuration, the standard configuration, which is him here. So our standard configuration is this is the version number and this is the section number, and then you have your key name and the key data. So the key name, that's just a strict type def, and when we add or take away from this strict type def, that then updates the database. So as long as you name those as unique, they'll just update the database. So you can see here, well, this is a different project, but if I showed you the same, I could show you the same project. Where this one comes from. So this project here is where this came from. You see the configuration has got a great deal more keys in it that are specific to this particular project, and all I'm doing is updating the strict type def, the type def. What's it on? Cool. I think I may have switched off the database machine, but definitely I've switched off my database. Hold hard. Right, that's errored because you can't find the database. A different database. Yes, I know you can't find it. I've turned it off for the night. So you can see here, this has got quite a lot of sections in it. It's just they build out over time. And then all I'm doing there, let's kill that, is updating the type def in here. There's that type def there, there's that type def there. It just gets bigger and bigger. And if it starts getting cumbersome, that's when we'll start to move it into different sections, to have different PIs that call it. So, you know, it's getting a bit big, that enumerated type. So I now might start just to sort of have a different system config, one for just the database setup or one for just the experiment setup, and start actually making this a bit more expressive, just because it's getting a bit big. Okay.
Yes. Yeah. Thank you.
No worries.
Nice.
So are there any more questions for Steve? It's quiet in the chat. So, well, I think we have come to the end of this online meeting.
So.
Steve, thank you very much for presenting, for your time. It was really amazing again.
No worries at all. Thank you very much for having me.